In this video, we'll be doing an example of factoring a quadratic equation with a leading coefficient greater than 1. Here's an example. 7z squared minus 20z minus 3. We want to factor this, meaning we want to write it as the product of two binomials. Something plus or minus something else times something plus or minus something else. We want these two things to multiply to equal 7z squared minus 20z minus 3. One technique to doing this is called grouping, and to do this technique, we first start out by drawing a big X just to organize our work. In the top of the X, we'll write the product of our first coefficient here, the one with the squared term, so in this case 7, and our last one that has no variable, which is this minus 3. Don't forget the minus. So 7 times minus 3 is negative 21, so that's going to go in the top of our X. In the bottom of our X, we put this middle coefficient, the one with the variable raised to the first power. So this, in this case, is negative 20. So that goes down here. At this point, we need to think of terms that will multiply to this top number and add to this bottom number here. Let's list all the numbers that can be multiplied together to equal negative 21. Since negative 21 is a negative number, we know that one factor will be negative and one will be positive. So for example, we could have negative 1 times 21. Those two numbers will multiply to equal negative 21. We could also have positive 1 times negative 21. Another possibility is negative 3 and positive 7, or positive 3 and negative 7. At this point, we've listed all the pairs of factors that multiply to negative 21. So now we want to see, do any of these add up to negative 20? Because remember, we want our two numbers that we're going to find, we want them to multiply to negative 21 and add to negative 20. These first two numbers, negative 1 plus 21, they would add up to positive 20. So that's not the right answer. These two, 1 and negative 21, would add up to negative 20. So that is a good answer. The rest of these are definitely not going to add up to negative 20. So the two numbers we're looking for are 1 and negative 21. So we can go ahead and write those in our X to keep our work organized. And now we're ready for the final step, which is to replace this minus 20z with 1z minus 21z. And so what we've done here is we haven't changed our equation at all. We've just rewritten minus 20 as 1 minus 21. So negative 20z equals 1z minus 21z. So this whole equation is still equal to our original equation. The next step is to factor out the greatest common factor of our first pair of terms in this newly written equation and our second two pair of terms here. With this first pair, the greatest common factor, or the greatest term that would multiply into both of these evenly, is 1z, or just z. So we can factor out a z from both of these terms. When we do that, we see 7z squared. When we factor out the z, that just becomes 7z, because we divide out a z. And 1z, when you divide out a z, just becomes 1. So these first two terms are factored completely. Now let's do the same to the second two. The greatest common factor of these two terms is minus 3, because minus 3 can multiply evenly into both of these. So now we're going to write minus 3. And then within our parentheses, we'll do negative 21z divided by negative 3. That gives us positive 7z. And when we divide negative 3 by negative 3, we're left with a positive 1. At this point, this newly written expression is still equal to our original expression. We've just rewritten it in a different way. But again, we're trying to factor it so that it will look like two binomials multiplied together. At this point, we see that both of our terms have 7z plus 1 in them, so we can factor out 7z plus 1 from this term, and we can factor out 7z plus 1 from this term. It's kind of similar to how we factored out a z from both of these two terms and a negative 3 from both of these two terms. We're factoring out 7z plus 1 from both of these two terms. This leaves us with 7z plus 1 times something in parentheses. Let's see what that would be. Our first term here, z times 7z plus 1, when we factor out the 7z plus 1, we'll just be left with z. So our first term in these parentheses is just a z. And in our second term, we have minus 3 times 7z plus 1. If we factor out a 7z plus 1 from this term, we'll be left with minus 3. So now we've factored out the 7z plus 1 from both of these two terms, and we're left with 7z plus 1 times z minus 3. And this expression here is still equal to this expression, which is equal to this expression, which is equal to our original expression still. So we haven't changed the value of the equation or anything. We've just rewritten it in a different way. And this form here, 7z plus 1 times z minus 3, matches the form we're trying to get it into. Two binomials multiplied together. A binomial being two terms added. If we want to check our work, we can combine these either using distribution or foiling. I'll use the foiling technique to check this. So first I'll take this first term and I'll multiply it by the first term in the second parentheses. That gives me 7z squared. Next I'll multiply the 7z times the last term in the second parentheses. That gives me minus 3 times 7z minus 21z. Next I'll multiply this 1, the second term in our first parentheses, times the first term in the second parentheses. 1 times z is plus 1z. And finally I'll multiply the second term in our first parentheses times the second term in our second parentheses. That gives me 1 times minus 3, which is minus 3. This minus 21z and the 1z are like terms because they both have the same variable raised to the same power. So I can combine minus 21z plus 1z into minus 20z. And we see now that when we multiply these two factors together, we end up with our original expression. So now we've just double checked and made sure that the factored answer we got is actually equivalent to our original expression. Now you may be wondering, why did we do all that work to factor this, to turn this to quadratic into the factored version? And the reason actually is that it's much easier to find the values of z that will make the equation equal 0 when it's in its factored version as compared to when it's in its regular quadratic version. And this is very useful in future topics related to quadratic equations. So this factoring skill is actually a very useful skill continuing on with algebra and even beyond. So that is an example of factoring a quadratic equation with a leading coefficient greater than 1.